Okay. Hello, everybody. My name is Josh Tan. I am the person who's going to be your tour guide today. We are very privileged today to be able to use this software, and we have our driver here, Micah, and he's going to be driving us through a tour of the solar system. Yeah. We're going to start at the Earth, and then we're going to head out to see the full solar system. We'll head over to Mars, look at some sites on Mars that might be of interest astrobiologically, and then check out a couple other sites in the solar system before looking at a totally different star system outside in the Milky Way. And so if we can zoom right on into New York, Micah, we're all gonna zoom in. If you have any questions, feel free to drop them in the chat. I'll try to check the chat every once in a while, and maybe we can answer them. Or if you have requests, we'll try to answer those as well. It's great. So we're headed down onto New York City right now. And hopefully many of the people who are watching are closely related to or located. So this system is very unique. It has sort of all of the real world data that you'd want. And the advantage of getting a view like this is that it gives you a sense, because so many of us are familiar with New York, it gives us a sense for the kind of detail and characteristics that we can expect to see when we go to other planets as well. We're going to treat the Earth kind of like a planet that we're exploring right now. So we can see Manhattan Island here, Central Park right in the center, the Onassis Reservoirs, that big lake in there. You can see the Hudson River and the East River on either side. And so this is where we'll start. And you can kind of see the curvature of the Earth in the background. It's very impressive if you can see this in a planetarium, but this is the best that we can do right now. So what we'd like to do now is we're going to try to fly up to about the location where the International Space Station would orbit the Earth.
All right, and here we go. And as we go, I'll just go up a little and then target it for us so we can go right there.
Okay. So we're actually going to head over to the International Space Station. Micah, is this where the International Space Station was located at some point, or where it's located now?
Well, I just have to zoom out a little bit so that we can get, so we don't fly right through the Earth when we go to it.
Mm-hmm.
And then we'll lock onto it.
All right, so we're actually going to head over to the International Space Station, which is pretty fun. As we get away from the surface of the Earth, we'll start to see the weather.
And here it is over the Pacific Ocean.
Okay, so you can see that yellow trail. That's the path that it has been traveling. And we're going to head over to the International Space Station right now.
And we can see Hawaii in the background.
Beautiful. And here's the International Space Station. So there are some misconceptions about the International Space Station. People realize that it's in space, of course, but I don't think very many people realize how close it is to the surface of the Earth. This gives you sort of an impression of that, right? You're in the realm of hundreds of kilometers away, which isn't that far, right? It's, like the next state over, but just directly overhead. Of course, it requires a lot of energy to get there, right? You got to launch rockets to get up there. But it's not, when it goes directly over your head, it's not considerably further away than, the outer edges of the city that you're living in, the metropolitan area that you're living in. So that's an interesting thing to think of. So we're going to follow the International Space Station on one orbit around the Earth just to get sort of a view of what that would be like to travel around on the International Space Station for one orbit. Just to give you also a sense for what it might be like to orbit around a planet. Since we're all familiar with Earth, it's a good one to start with. And then later on, we'll actually look at a different planet, Mars, and perhaps Venus, to see what it's like to orbit around those and get a different sort of view of those planets. Off we go.
So now I've sped up time to save us some time.
Thank you.
And we're going at 30 times speed now.
Yeah. So you can expect that if you were to, be on the International Space Station, you could tell that things were moving, but it would be at a much slower clip. So we're following it along at a much faster clip. And so if it's 30 times the speed, we should be able to get around the Earth in about a couple minutes or so. Still, the Earth is quite large, so it's going to take us a bit to get around. And you can see that the rendering of the different weather patterns is coming through there. So you might be able to catch a glimpse of what the weather was like. I guess that's the weather from yesterday. Is that right, Michael?
Yeah, that's yesterday's weather, because today's weather isn't over yet.
Mm-hmm. So here we are headed over to the night side. And as we get onto the night side, you might be able to tell that there is still an Earth beneath us. When we're over oceans, of course, you can't tell. It's just completely dark. But occasionally we'll pass over some land, and you might be able to see some cities pass through. We can also get some views of the constellations that are right above the limb of the Earth. And there's some cities that we're going beneath right now. Sometimes fun to try to figure out what continents or bodies of land you're flying over. It can be a little bit difficult to identify, especially at night. During the day, it's much easier because you can make out the borders of the land. I'm not exactly sure where we are. Somewhere perhaps in Asia? Is
Must have been,
possible?
because such a sprawled city.
Mm-hmm. But soon we will be headed over, and you'll start to see that the sun is peeking through the horizon, and now we're going to see sunrise on the International Space Station. So that sunrise happens about every 45 minutes. It's sunrise and sunset. You get to have these sort of rapid transitions between day and night. And so because of that, obviously, you can't go by the position of the sun for what you're expecting your day to be like. So here's morning, I guess, at the International Space Station, except it's, one of a dozen mornings you get every day.
That's a neat. I never thought about that they have multiple mornings.
Yeah, multiple mornings, multiple nights. There's a nice little viewing portion for the space station too, called the cupola, which sticks out that you can see the Earth from. And I think, are we back to where we started yet?
Yeah, here's Hawaii right here.
Comes Hawaii. So that was one orbit, one pass of the International Space Station all the way around the Earth. We're going to do something similar when we go to some of the other planets as well. But I wanted to give you a sense for what that was like, because we're all very familiar with the Earth. We're familiar from maps and from thinking about what different people that we know and love are located on this planet. It's a big place, obviously, but we're going to be kind of traveling to much larger and more expansive locations. So the next thing I'd like to do is to leave the solar system entirely and get a sense for what the scale of the solar system might be like in its entirety. So we're going to zoom away from the Earth at faster and faster speeds, and we'll try to follow along with the paths of the different planets as we get further and further out. We should be able to see more and more planets in our field of view. All right, so the first planets that we're going to see, we should be able to see the moon coming around the Earth right now. That's the path of the moon. And you can start to see some of the other planets out in the distance as well as we get further away. So there's that inner planet is Venus, and the outer planet is Mars, and there is the Sun and Mercury, and now Jupiter's coming into view. So we're getting a full view of the solar system. We're going to try to get fairly far away and then do a sweeping tour all the way around. So you get a sense for how flat the solar system really is in the context of the cosmos. So as we get further and further out, you'll see the paths, and then we can go very, very quickly as we zoom around, right? This is extremely fast. What we're traveling right now, much faster than the speed of light, for example. So this is only something that you can appreciate by using planetarium software, but it gives you a real sense for the geometry, for how everything is oriented with respect to the sun. And also you can see in the background, there's this really bright Milky Way. This is the collection of the majority of the stars that we can see. And that's the sort of overall structure for all the stars that are nearby. It's in this giant disk that surrounds us in the sky. But of course, we live in a different disk that's oriented slightly differently, that orbits around the sun. And you really get a nice sense for the fact that the solar system is in this disk, if you can kind of see it from this perspective. So we're going to zoom now to Mars and get a nice view of Mars. So remember, Mars is the 4th planet from the sun, and we're headed straight towards it at incredible speeds. Remember, it's probably about 20 or so light minutes from the sun to Mars. So we're just far outpacing the speed of light by doing this sort of tour. And here we come on in. Here comes Mars, is our ultimate goal. And you can see there are these paths that are circling around Mars, now turned off, but what those were, that's all right, you can turn them off, but what those were the small moons of Mars. These moons of Mars are very, very tiny. They wouldn't be visible as actual disks on the surface even. They would just look like these sort of bright stars in the sky that would be moving rather quickly around. So we have this nice view of Mars right now. There are some very interesting features that show up on Mars, including some of the biggest mountains, extinct volcanoes in the solar system. There's a giant canyon system called the Valley Marineris, which we're sort of seeing in view right now. But we're going to try to get as close to the surface of Mars as we did when we were orbiting around the Earth and the International Space Station, just to get a nice little view of the globe, of what we might expect if we were to come close to Mars. All this is real data, it's important to emphasize, right? So what has happened is that many different missions have traveled to Mars to view and get information using orbiters, and also there have been a number of landers that have landed on Mars. But the orbiter data is basically the equivalent of our Google Earth for Mars. And this enables us to really see incredible detail on the planet. So once we get to about a height of the International Space Station or something equivalent, we'll head off in an orbit around. And you'll get a sense for how different Mars is from the Earth. There are certainly similarities, and we'll try to point those out as we look at them. But one of the main differences that people, almost always notice is the color. It's just a substantially different color. Mars is the red planet, Earth is the blue planet. So we're following along here, these giant chasms that were formed through tectonic activity, and some of them may have been enlarged or enhanced by flowing water way back in the past of Mars. There's no water to speak of on the surface these days. It's too cold and also very dry. But this is the sort of same view that we had over the Earth. So of course, unlike the Earth, as we go around Mars, we won't get to see any city lights to guide our way, but we can still get the sense for what we're doing. Mars is a smaller planet, so if we were traveling at the same speed as we were traveling around Earth, we would get around Mars a little bit quicker than the Earth at the same level of orbit. But because Mars has less gravity, it tends to sort of even itself out. Like the orbital speed around it is a little bit lower. And so it takes about the same amount of time to calculate it out. Here comes sunrise. Sunrise on Mars. And if we have any questions, feel free to drop them in the chat. So here we are, here's sunrise on Mars. We're heading across. And as you pass over the features of Mars, you'll see a lot of these sort of circular pock marks hitting the surface. These are all the craters of Mars. Mars does not nearly have as much, and we actually see the largest mountain over on the left. It's Olympus Mons. But the craters on Mars, a lot of them that you see are from meteorite impacts that happened millions of years ago in many cases. And on the Earth, they would be erased by tectonic processes and erosion. And on Mars, they persist for a little bit longer. There are processes that will eventually erase craters on Mars. It's not as heavily pockmarked as the Moon or Mercury or other worlds that have less atmosphere and less activity than Mars did. But it still is a much more cratered world than our Earth. So we're going to head now to an interesting site. This is a famous site that we often go to called Kandor-Chasma. And the reason that we like to go to this site is there seems to be substantial evidence that in the past this may have been a site that had some water. And we'll look at this carefully. We'll travel around it. It's also a somewhat, I think it's a strikingly beautiful site in terms of terrain. It's an offshoot of that big valley, the Valley Marineris, that stretches a long way around, across Mars. It's the longest, deepest canyon in the solar system. So this is sort of a chasm that's an offshoot of this giant valley. But we're going to get some incredible data here. This data is, I think, well, Micah can let us know, correct me if I'm wrong, but it's down to smaller than a meter in scale.
Yeah.
We can see.
So the surrounding area is at 6 meters per pixel scale, and the small inset area that we'll be going to has 25 centimeter per pixel of resolution. So that's something about the size of a laptop you'd be able to see there.
Right, and so this is real data. This is actually what this area of Mars is like. And it's really fun to sort of swoop in on this because you really get the sense for the geography and the mountains and the terrain of Mars as you come in on this. Now you can kind of see that little sort of discoloration. That's where we have the best data, that sort of postage stamp that's being indicated here. And you can see these switchbacks that are flowing back and forth, perhaps indicating the flow of water. It's a little bit difficult to know. Some of these things that we're seeing are also formed by wind processes, but there seems to be a lot of layering that's occurring in this area. And the layering is very indicative of periods of time where water sort of lets the material settle down and you end up building layer after layer after layer. That's what we would indicate here on the Earth. Maybe you're at the shore of some sort of sea. Maybe you're seeing the flowing channels of water. This would have been billions of years in the past when water was actually here. No longer here now, but this is a kind of an amazing view. And so if you think about this, sort of the smallest features you're seeing here are on the scale of, you know, smaller than the room that you're in right now. Just amazing to think about. This would be like what it would be like to kind of take a ride down onto the surface of Mars and look around. You can see up into the sky as well. You can see that it's sort of this reddish brownish color up in the sky. And we'll just take a nice little tour here. You can see the mountains off in the distance. Of course, Mars has quite a lot of dust and debris and there's famously lots of these sandstorms that will get kicked up from time to time across the planet. And they'll sometimes engulf the entire planet in these sort of red dust sandstorms in sort of amazing fashion. But here we go, just sort of taking a little tour of our surface features here. And interesting to think about different places that you have seen that are similar to this. I always kind of feel like, when I go out to the beach or something like that, I tend to see a lot of these sorts of features. And that's not surprising, as a lot of the features on sandy beaches are formed by wind. And so a lot of the features that we're seeing here that are formed by this lighter sand are also formed by wind. You see dunes and things of that nature. So we had a question about whether we'll see where the Martian was located. Where was that located? The hub. I forget where precisely it was. If you remember exactly where it was, we could certainly look at it from the surface, but I don't know if we have the high quality data that we need.
Yeah, I actually was just talking about this recently, but also forget exactly where he was. But if he was here in the picture, we would see him.
I can check quickly here where the hub location was. I don't know if it's specified very carefully in the text. I forget exactly where the hab. So I always find that this sort of view is amazing, with the sort of high outcrops all the way around. We're sort of down in the valley, and you can imagine kind of traveling up to the top of one of those hills off in the distance. In fact, it's doable. You can actually climb up those, although we'll leave the high resolution area when we do that. But you can really get the sense that there's some interesting things happening on the surface, whether formed by wind action or some of the larger switchbacks are very reminiscent, to me at least, of the way water would flow on it. So we're actually looking out over to Orion up in the sky. We're going to head up a little bit here. Bethany's going to try to figure out precisely where the Martian was. We can go see if we can find it on the planet.
Yeah, I will just see if I can find real quick. It was between Tharsis and North Vallis, so I think I know where it is.
Okay. Well, that's where we'll look next. I don't think we have high quality data from there, but we certainly can look at that location. Yes, we're actually not too far away from that location right now. Here's the coordinates: 31.2 degrees north, 28.5 degrees west. So we're looking over Tharsis right now. On this side, okay. Perhaps you could try to enter the coordinates. Okay. Up near the Terminator. Yeah.
Where he was in this dark area up here.
Okay.
And I can turn on these medium resolution strips, but because it's so too close to the pole, we don't have the higher resolution strips.
Right. So we can get a fairly good view, but we won't be able to see much better.
He was in this region here, this flat region, but I'm not sure exactly where in this region.
Yeah. All right, so that's our first pit stop. What I would like to do next is to travel to the next planned landing site on Mars, which is a unique crater. So this is where the Mars 2020 mission is slated to land.
And that's the Jezero crater.
Yes. And this crater is quite unique. Well, I mean, there's actually quite a few craters that are sort of similar to this, but it has a feature that is unmistakable. As we come into it, hopefully you'll see.
So we just need a sec for the higher resolution to load in on us.
Okay. So yeah, there's quite a lot of computational power that goes into rendering all of this.
So here we can see the crater rim and the delta.
So yeah, if you look up towards the top of your screen, you're going to see some interesting things that appear to be entering into this crater. And as you look above, you can kind of see some snaking feature that seems to be coming into the crater. So the idea here is that there may have been flowing water that flowed into this crater, creating the equivalent of a crater lake. It's almost certain that this is what's happening. And as we get closer into this feature, what you'll see is the same sort of thing that was seen, that is seen here on Earth when you have water that flows into a wider body. This is sort of delta feature that we have. So the sediment and the material from upstream comes and gets deposited downstream. And there are certainly layers that are viewed, that you can actually look and see, that appear to be indicating that there was multiple episodes of putting the material down one on top of the other. And you can imagine that this would be a very intriguing site to land and explore, hoping, well, first of all, to identify that this is actually what was going on, but also you can imagine that if there were living things, you might be able to see their features in some of these layers if you had the right tools to be able to extract the evidence from whatever has been laid down here. So this is the delta of this crater. This is the goal for the Mars 2020 mission down here. Real incredible view too. And I'd like to let everyone know who's watching that if you have any questions or requests, we are taking them as we are traveling around here. And so let us know if there's something interesting that you want to check out or see or experience. But these were the two big locations I wanted to make sure that you all saw on Mars. The only other thing that I think is nice to see, which I might ask Micah to give us a view of after we finish traveling around here, might be the polar ice caps on Mars. A lot of people are aware that Mars has some pretty amazing and extensive polar ice caps. You have to get pretty high up to be able to view them. So you can definitely get a sense for these layered features here, and then you can see some of the material that has come off of the blown sand from the top. Comes off onto the bottom. The American Museum of Natural History frequently, or from time to time, gets experts in the geology of Mars to come in and give incredible tours. I've been fortunate to be able to see one or two of those. They're just amazing things. And people have extreme familiarity with everything that's on Mars, and just can expound for, it seems like forever, about all the different features that are there and what they might indicate.
It's amazing how much detail they know about the surface of another planet.
Will devote their entire lives to thinking about Mars. And you can see a crater off over on the left-hand side of the screen. So craters are extremely important features for a number of reasons, but one of the more interesting ones is that they can help provide ages for surfaces. The more craters you see, the older the surface. As you think about, kind of as though you're in a rainstorm, you go out and you only get a few raindrops, you weren't out in the rainstorm very long. But if you get soaked, you were out for a much longer time. It's basically the same idea with craters on a surface. But there are some things that can erase the craters on a surface. Weather patterns, processes like eruptions. Mars is no longer tectonically active. It doesn't have active eruptions, but in the past it did. And they would go ahead and repave the surface. It's actually the words they use, repaving. So maybe we'll head out here, far away from the surface of the planet, and can we get a view of one of the ice caps? Northern or southern? I don't think it matters too much.
Yeah, I think we can get a better view of the southern, maybe.
Okay. Oh, we had a question. What was the height of the ridges at the crater? That's a very good question. I'm not sure I know the answer to that.
Yeah, I should with the number of presentations that I've done
The
about it, but
crater
I don't.
walls, I believe the crater walls are something like half a kilometer, but I'm not sure. Yeah, I'm not sure how high those are, unfortunately. Okay, so we're getting a nice view of the surface of Mars right now, and we're going to head around down to the polar ice cap. It's all right. Here we go. Yeah, they're unmistakable features. And they get larger and smaller depending on what season Mars is experiencing. So in a southern hemisphere summer, the ice cap shrinks substantially and then it grows out. You can kind of see where the edges might be. There's definitely a substantial amount of ice beneath sort of a layer of sand or the Martian soil that has been deposited on top of it as well. The ice caps on Mars are made mostly of carbon dioxide, dry ice. But there has been at least one lander that has landed at the northern pole and has discovered evidence for ice water existing, at least temporarily right beneath the surface. And so there is some ice water there as well, but it's far and away predominantly carbon dioxide. This is just another way that Mars is very similar to the Earth, apart from having all these mountains and hills and valleys. It also has this these features that are similar to the Earth in terms of its polar regions, and has seasons as well. Mars has these the warm and hot seasons and cold seasons associated with summer and winter due to the tilt of its axis as well. Okay, so that was a fun visit to Mars. There's a few other places I'd like us to go in the solar system that are relevant. So this is a presentation that's done for the Life in the Universe class. And Mars is certainly an important location to consider, but there are some others that we might consider as well. So I'll just take you to a couple other planets that might be of interest. Let's start off by going to Venus. So Venus, in many ways, is considered the twin to Earth, but it hasn't had as much focus or emphasis on it as Mars has, probably for some good reason. So Venus is closer to the sun than the Earth is. So Earth is the blue streak, and Venus is this sort of reddish streak that's a little bit closer to the sun than us. And so that would mean it'd be a little bit hotter. Mars is obviously colder than the Earth, Venus a little hotter. But you might not expect it to be as hot as it turns out to be. It's hot enough on the surface of Venus to melt lead. And the reason for that, we're going to shortly see as we get closer and closer to the planet. So while there have been many, many missions to Mars, the missions to Venus are not as many in number. And basically part of the reason for that is because the surface is so ridiculously inhospitable. It's kind of impossible to imagine any sort of life surviving on the surface. And the reason it's so hot is because it has an extremely thick atmosphere. And this thick atmosphere is supports an incredibly rich and thick cloud structure, which is what we're seeing right now. So we can't actually see any of the surface of Venus. We're really looking at the cloud layers of Venus. And what's interesting about looking at the cloud layers of Venus is that even though they're well above the surface, if you measure the temperature and the pressure of the sort of predominant cloud layer, it's about the temperature and pressure that we're experiencing right now here on Earth, which is pretty remarkable. So if we look at that sort of cloud layer, there's this very characteristic kind of V that's indicating that there are some rather rapid winds that are circulating around the planet. That cloud layer is sort of in a comfortable zone. So if you can imagine living in the clouds of Venus, that might be a little bit more acceptable, certainly more acceptable than living on the surface. The problem is that that cloud layer is also sulfuric acid, so not exactly conducive to the living things. You don't really want to live in a sulfuric acid environment necessarily. It's also extremely dry, very, very little water from what we can tell. But there might be a little bit of it in that layer. So there have been some proposals to investigate the clouds of Venus. But we can also kind of like delve into the clouds a little bit if we'd like. If we dive in a bit, we can look at what the surface of Venus might appear like. This is data from a spacecraft that actually bounced radar off the surface called the Magellan spacecraft. And it was able to penetrate through these layers and see some surface features, features that indicate that in the past, Venus was active. It's no longer active seismically, and that there might be some really interesting things that happened in the past. It's interesting to think about whether in the past Venus may have actually been more hospitable to life, and whether any evidence might be still something we can find on the surface. Hard to know and hard to really decide whether that's the case. And because the surface is so ridiculously hot, there haven't been very serious proposals for landers to go investigate. So it's not necessarily the best place to go visit, but it is our other twin, right? Sometimes Mars is considered the twin of Earth and sometimes Venus. Things went really wrong on Venus in terms of heat, just as they've kind of gone wrong on Mars in terms of cold. But it might be easier to imagine supporting residual life in an extremely cold environment than in a hot environment. That might explain the reason why there's not so many missions to Venus and movies about going off and meeting all the Venusians. So that's our view of Venus. Maybe a little disappointing, but there's still some intriguing things going on. What I'd like to do now is go out further into the solar system and look at another object, not a planet, but a world. This happens to be a moon of our largest planet, Jupiter. And we're going to head out to a different world. This world is the planet, or rather the world Europa, that's orbiting the planet Jupiter. So as we head in towards Jupiter right now, Jupiter has 4 rather large moons. These were the moons that were discovered by Galileo 400 years ago when he first pointed his telescope at Jupiter, realized that there were these things that seemed to be following along with Jupiter. And the second closest moon is Europa. And Europa has been very intriguing for a long time, ever since we first flew space missions past Jupiter and began to investigate it. we realized that there were some features that indicated something rather remarkable about this world, this moon. And as we come on to this world, we should begin to see these features. So there's Jupiter in the background, but we're going to focus in on Europa. And as we get close to it, you can see that it is sort of a grayish, whitish color, for starters, but also there are these giant cracks that are running along the surface. And investigation has actually shown that what we're looking at is basically a surface of water ice, and among other ices. But that beneath this water ice, these cracks are indicating that what's going on is that there is an entire ocean of water. In fact, more liquid water beneath this surface than there is liquid water on planet Earth, which is absolutely incredible to think about, that there's all of this liquid water. Liquid water is the stuff that we think of as being necessary for life. On Mars, we're just trying to find evidence that it once was there, or maybe there might be some left way deep beneath the surface and life is hanging on. We really don't know what's going on in this ocean beneath the surface of Europa. It could very well be that there are living things there. And so there are definitely proposed missions to go visit this moon to investigate it further. Trying to get beneath that surface is a bit daunting to think about. We do have drills here on the Earth that will go miles down into an ice shelf or something like that. But you're talking about thicknesses of this surface that are like 10 times the thickness of ice that we drill through here on the Earth. So it's not quite what we're capable of doing yet, even on Earth. And imagining transporting this to another part of the solar system is pretty daunting. But there are other ideas that people have for how you might investigate some of these things. There are actually geysers that have been discovered, material that's spewing out of Europa, and it might be possible to fly something through that material and pick up some evidence of maybe something that's happening in the oceans. So Europa is an extremely intriguing environment. In fact, some people think it's more promising for having life than even Mars, just because it could be in that ocean deep beneath the surface. But we haven't had a mission to Europa yet, although there are some that have been fast-tracked. And so I think in the near future, in our lifetimes, and many of our lifetimes, we'll probably have the pleasure of seeing some missions to Europa. So Europa is one intriguing location in our solar system to think about life. But now we're going to head to yet another moon, not of Jupiter, but this time of the next planet out, which is Saturn. So Saturn has a number of medium-sized moons and one rather large moon. The largest moon of Saturn is Titan, interesting in its own right, and there's been a recent mission that was proposed to Titan that may fly soon. It is unique in the solar system as it has a very thick nitrogen-based atmosphere, which is similar to the Earth's. But although people once thought maybe there could be interesting life forms on it, it doesn't seem to be as intriguing, at least to me, in terms of thinking about life, as another moon of Saturn. And this moon is very similar to Europa. The name of this moon is Enceladus. Enceladus is a small moon. It's one of the smaller, the medium-sized moons. So Titan is a big moon. Enceladus is a small moon. But as we come up on it, I think you'll see why it's so intriguing. And actually, there's even more intriguing things about it that I can mention once we get to it. So here we pass by the beautiful rings of Saturn. And Enceladus is quite close to Saturn, in fact. Moon's off in the distance. And here comes this tiny little moon Enceladus up here. And as you get close in onto Enceladus, you can see that it has very similar features to that which we were seeing on Europa, right? These big cracks on the surface. Not quite as striated, and there's also some indication that there's actually been shrinking of the planet at some point. But one of the reasons this particular moon is so intriguing is that I mentioned before that there have been geysers discovered coming out of Europa, but Enceladus also has geysers. In fact, the geysers coming out of Enceladus are extremely dramatic and unmistakable. They were the first sort of water geysers that were discovered outside of the Earth, which is very indicative that there's likely an ocean of water beneath the surface of Enceladus as well. Indeed, many of these ice moons out in the outer reaches of our solar system could have oceans of water beneath the surface, not just Europa and Enceladus, but many, many others as well. All intriguing worlds to be thinking about. The reason that water can actually be in liquid form way out here at the edges of the solar system is that the planets, rather the moons that are interacting with their host planets and some of the other moons in the system, experience sort of tidal stretching back and forth that heats the interiors and keeps it warm enough to be able to have this layer of liquid water beneath that solid ice crust. And so this is something that seems to be appearing in a lot of these systems, in not just Jupiter and Saturn, but also in even further out than this. There could be ocean worlds deep beneath the surface of these moons. And so this is something that people who are interested in astrobiology really think carefully about whether or not this is the primary place to look for life. So far, Mars gets top billing, right? Most people, if you sort of survey them, they say, let's go to Mars, look for life. But I think we shouldn't overlook these other possibilities as well in our solar system. Okay, so that was what I wanted to show everybody in the solar system. But before we end right here, I think I'd like to go to a different solar system. So we've kind of looked at some of the objects in our solar system. And now I'd like to look at the artist's conception of a solar system that was discovered a few years back by a consortium called the Trappist Consortium. This was a consortium of telescopes that were attempting to discover planets around other stars. And the first and most spectacular discovery that they made was a system that they named TRAPPIST-1. So TRAPPIST-1 is quite far away from our solar system, so away we'll have to leave. And we're going to head out through sort of, this is the haze of the light from the sun that's now going to get dimmer and dimmer as the sun becomes just another background star. And as we get further and further away, you'll start to see other stars begin to move. Those other stars are moving because we're actually moving in perspective with respect to them. But we're headed out towards a star, not a particularly noticeable star, but it's a star that surprisingly had a large number of planets discovered around it. So the large number of planets that were discovered around this star is quite intriguing. And if you look at this, it's not unlike what we just saw here on Earth, right, or for our solar system. This is a star that appears to have, let's see, I guess there's 7 planets orbiting it, right? Whereas we have 8 planets orbiting our own, right? And very intriguingly, this star is a little bit colder than our sun. And because of this, even though the planets are orbiting closer in than the planets in our solar system, they might not be much hotter. In fact, they might be about the temperature that we're enjoying here on Earth. In fact, more than one of those planets may be. We can't actually see any features of these planets. We just know about their existence and roughly some things about their size and not much more. They're so far away that we just don't have the techniques and technology to really get better information about them. That doesn't stop people from guessing and speculating. And so some artists, together with scientists who study these very carefully, have put together some artistic rendering of what these planets may look like. And so we can fly in and view some of them. So perhaps we should just look at one or two of these planets to see what artists think of them. I'm not sure which particular planet this is, but you can see that the artist's conception for this one is that perhaps there's liquid water on the surface of this planet. Not necessarily outside the realm of possibility, considering how the temperature you would calculate for this planet. Of course, it could be that there is no liquid water at all. It could be very hot because it has an extremely thick atmosphere like Venus, or it could be very cold because it lost all its atmosphere like Mars. We don't know. We just know its distance and we know approximately its size. And here's another one. I think the artist thinks that perhaps this one might too have liquid water. More than a few of them are sort of in that sweet spot. Sometimes we call it the Goldilocks zone, or sometimes we call it the habitable zone of a planet, planets going around the star. But to be honest about this whole thing, we really do not know much about what is on these planets. It's sort of an active area of research. It's something that everyone is interested in and people want to find more and more about. And so it's going to require better technology, better telescopes, better studies to really figure out all of these things. I guess we're going to the closest one in. So I'm guessing that they believe this particular world might be totally covered in oceans. I don't know. And no one knows. It's pure speculation for the most part. So that gives you a sense for some of the things that we can look at here and kind of investigate. There's a lot more to this planetarium software in this program than what you have seen. And I'm happy to take requests and suggestions, answer questions at this time. I like to spend about an hour doing these programs. Much more than that, it's a bit information dump overload. But I thank you very much for joining us. This will be, of course, recorded and will be shared, I hopefully seen by a number of people who couldn't make it tonight for one reason or another. But we'll wait a little bit to see if there are any questions or requests. And if there are, we'll try to answer those as well as we can. But otherwise, thank you very much for joining us. And I hope you enjoyed our little tour of the solar system and other possibilities for where life might be out there in our galaxy. So I'm looking at the chat right now. I don't see anybody responding. So hopefully that means we gave everybody a good show and they're really happy about what they got to see. I'm hopeful for that. So the question, could we identify some constellations in the background? Thanks, Gary. Thanks, Nancy. We can. Micah, do you mind turning on the constellation features? So these are the sort of lines that indicate the constellations. I think we might be able to turn on some of the names as well. It's a little bit awkward because we're actually near the Trappist system, so it's a little hard to get your bearings when you're on a completely different star system. And the constellations here actually look very different because we're far enough away that the stars don't look the same. Let's go back to the sun so that the constellations, but we'll actually, this is a fun thing to do anyway. We'll see the constellations morph into the actual shapes that they should have as we get closer and closer to the sun. So this red constellation that we're actually headed towards is the constellation Leo. Right, and then up above here, we've got the Big Dipper, Ursa Major. There's the sun. Yep, so there's the Big Dipper. Now we're basically now back close enough so that the constellations are the same, the Little Dipper. So we're looking up in the northern part of the sky, right? That's Polaris is at the handle, the Little Dipper that's right above the sun right now. Draco. So these are the northern constellations. If we spin around 180 degrees, we can see the southern constellations, which, unless you've been to the southern hemisphere, will look very unusual. This constellation Boötes there with Arcturus. It's a bright red giant that's going to be the fate of our sun eventually. And as you head over, you can see that the Milky Way dominates sort of this band around the galaxy here. And now we're headed over into the southern part of the skies, right? On the Earth, it'd be southern part of the skies. You can see two little clouds. There's the clouds of Magellan, which are the sort of nearest satellite galaxies to our own. And we're looking out basically down in the southern part of the sky right now. It's the Southern Cross. So there's the constellations for you. Of course, these lines are never there to help you when you're looking at night, but it's nice we can turn them on ourselves in the planetarium. Any other questions or desires? Yes, that's true. I should point out that you can download this yourself. It does take a little bit of work, but I've gotten it successfully to run on my computers. Helps to have a good computer to run it. You get much better working conditions, but I've done it on even old Macintoshes. Able to handle it. So here we head back to Earth, where we began. It's great. Home sweet home. I could see the International Space Station arc heading out across it. It's great. Okay. Well, thanks everybody for joining us. I'm going to call it now, but thank you also, Micah, for driving us around, being a great host. And thanks to the OpenSpace Project for doing this. This is absolutely amazing stuff. And so I hope you enjoyed your tour. And after this pandemic is over, come to one of the many planetariums in New York that are using them and enjoy for yourself, including the Hayden Planetarium at the American Museum of Natural History, and also the City College of New York Planetarium in the Marshak Science Building also runs within space. Okay.
Great, thanks.
Thank you.